Hi kids, I just wanted to come on and post the video and go over our theoretical and experimental probability. These were in your packets. It's the packet that looks like this. It says experimental and theoretical probability. We'll talk about what that is and what the difference is between the two, and we'll do a couple of different experiments with it while we're going through it. Okay. All right, first let's just talk about what is experimental and theoretical probability. What is the difference? So this is kind of one of those where sometimes we may make a guess. We may make a prediction based on what we know. And what we taught you, or what I've taught you about probability, is it's the number of desired outcomes divided by the total number of possible outcomes. Well, we use that information and we know that based on that, what we know about probability, we should get a possible result. And that's the theoretical probability, what we expect to happen, what it really should be. Um, we sometimes we will test that, especially when we're doing science experiments and we go through our steps of the scientific method. Here's my clock. You guys are used to hearing that now, aren't you? But we need to test it out. Sometimes we need to see how many times the event is going to occur. We need to know. It just doesn't need to be a guess. We actually need to find out. That's when we do an experiment, and that's where we get experimental probability. The experimental probability is the result of an experiment or a simulation after you do it a whole bunch. The way to replicate a good science experiment is to be able to do it over and over and get the same results. So we can relate this kind of to science too, especially when you collect data. Your data should get a lot closer to accurate, or become a lot more accurate, the more trials you do of an experiment. And we'll talk about that just a little bit later, probably in science. So let's look at this first page. Okay. And it lists out the definitions, or kind of the formula for experimental probability first. And it says that experimental probability is the number of times an event occurs divided by the total number of trials that you conduct. I'm going to change my pen ink here. Okay. So it's the total number of events, or how many times something occurs, divided by how many times you try it out, how many trials you went through. The example that they give for this is that you check 20 cartons of eggs. 7 of the cartons have at least one cracked egg in them. What is the experimental probability that the carton of eggs has at least one cracked egg? Well, you know that you have found at least one cracked egg in 7 cartons, so 7 times you have found a cracked egg, divided by the total number of trials, and in this case the trials is how many total cartons did you check, and it's 20. So the probability of finding a cracked egg out of those 20 cartons is 7 out of 20. Okay, we could put that into a percentage, and that would be about 35%. So about 35% of the cartons have a cracked egg. That's a lot, especially considering there's hardly any eggs in the grocery store right now. All right, moving on. Theoretical probability. Now, theoretical probability is the number of times that an event should occur, or you would expect it to occur, divided by how many trials you're going to do, or how many trials you do. The example that they give for this one is using the word example over to the left, and it asks that you randomly choose one of the letters that is shown. What is the theoretical probability of choosing a vowel? Well, in this case, we have to figure out, one, how many letters are there, and we need to figure out how many vowels are in there. So there are 7 letters in the word example, and there are 3 vowels. There's 2 E's and an A. Okay. So if you're testing to see how many vowels you would choose out of this word, your theoretical probability would be 3 out of 7. 3 out of 7 letters are vowels. And once again, if you wanted to check real quick and see what the percentage of that is, that's about 43%. Okay? I usually like to try to figure out what the percentage is, just because that kind of makes more sense to me. All right, moving down to the practice. This says that you use a spinner to determine the theoretical probability of the event. Okay, the little spinner over there to the side has 8 numbers on them, even though they're kind of hard to read. There are 8 numbers. And the first one says, what is the probability that you're going to roll or spin an odd number? Well, if there are 8 numbers on there, we know that 1, 3, 5, and 7 are all of the odd numbers. If you were to spin it one time, you have a 4 out of 8 chance of spinning an odd number, or you have 50%. There's a 50% chance that you will spin an odd number. The second one says, what is the probability that you will spin a 3? Well, when you look at the spinner, you'll see that there's only 1 3 on the whole spinner. So there's a 1 out of 8 chance that you will spin a 3, which reduces to, or excuse me, which can be stated as about 13%. And it's actually 12.5, but we can round it up to about 13%. Okay, because we're spinning a 3. And then the last one here says, what are the chances, or what is the probability you're going to spin a number that is a multiple of 2? Well, we know that numbers with the multiple of 2 are 2, 4, 2, 4, 6, 6, and 8. Those are also all of the even numbers on the spinner. And so it's pretty much the same as the odd numbers. There are 4 numbers out of the 8. So there's a 50% chance that you will spin a number that is a multiple of 2. Okay? Then the word problem at the bottom says, the table shows the results of flipping 2 coins 12 times each. What is the experimental probability of flipping 2 tails? Okay? Well, in this case, our desired outcome, or what we're looking for, is how many times did we flip 2 tails? And it's right there. 2 tails. Tails, tails. There are 3 times that we flip 3 tails. Or excuse me, 2 tails. Okay? And then here it says experimental probability is the number of times the event occurs divided by the total number of trials. So in this case, we had 12 times. That's how many times we did it. Okay? So 3 out of the 12 times we flipped 2 tails, which is the same as 1/4, or 1 out of 4, and that's 25%. Okay? So there's those examples on the first page. Next page. For the next page, you're going to need to go visit your vocabulary page, or the vocabulary list in Quizlet. Okay, so let's move over to Quizlet, and it takes a second for this page to load. There it is. Okay. So the first one on the top of that page, it's giving you the definition of experimental probability. And it's, whoops. Flip it over. There it is. And here's where you'll fill in that page. It's asking for the definition, and it says the experimental probability is the ratio of the number of trials an event occurs to the total number of trials. And we can sum that up, or just kind of say whoops. Come on, cooperate. The experimental probability is what actually happens. It's what actually happens. The next one is theoretical probability. And the definition for theoretical probability is the probability of an event happening. The probability. Wow. Okay, I'm having some technical difficulties here. Probability, there we go. The probability of an event happening based on the possible outcomes. This is what could happen. What could happen. Okay. And that's for you to fill in the definitions there at the top of that page. Okay, so we're going to go back over here. Those go up here in this box. The second part says use the spinner below to answer the questions. Then spin the spinner 10 times and complete the table below. Okay, well, obviously you can't spin this one, so I'm going to show you where you can go get a spinner and try these out, do these trials. But first, let's talk about the theoretical probability. Okay, theoretical probability meaning what's likely to occur. So what is the theoretical probability of spinning a section with stripes? Well, theoretically, you should land on stripes. Your chances of landing on a stripe is 1 out of 8 because there are 8 sections there. So the theoretical probability of spinning a section with stripes is 1 out of 8. And that's about 13%. Because there's only one with stripes. Next, it says, what is the theoretical probability of spinning a section with stars? Well, there's 2 sections with stars, so this would be 2 out of 8. There would be 2 out of 8, or 25% chance of spinning a section with stars. Okay, then the last one says, what is the theoretical probability of not spinning a solid or striped? Okay, so we got to figure out how many are not solids and which are not stripes. Well, there's 1 stripe and there's 4 solids. So there's 1, 2, 3, 4. There are 4 non-striped, non-solid spaces left after you take away the stripes and the solids. I believe that's right. Nope, that's not right. There's not 4 spaces. There are, sorry, I'm having to look here at this little screen. Taking away the stripes, taking away the solids, there are 3 spaces left over. There's 3 out of 8 spaces left over. Okay, so the chances of spinning a space that is not stripes and not solids is 3 out of 8, or about 38%. Okay, I think that's right. I think I brought that. Hopefully I read it right. Okay, for the next table, you're going to need a spinner. And I've got a link posted. If you go into Canvas, on the page, the next page, there is a link and a picture of an online spinner. I'm going to try, here we go. There we go. So I've already set this one. You can change the number of sections in there, and I've got this one set already. So if we were to set this to 10, if we were to set this 10 times and spin it 10 times, you can spin it and it'll fill in the table here. It's going to give you your experimental probability and your theoretical. And you can sit and watch it. Excuse me one second. Just come on in. Come on. Just, or you can skip to the end. Okay, and then fill in your table there. Well, what I did with mine is I just went through and I listed each one of mine on my paper with the color around there. So my blue one is actually the stars. And so it tells me that we got stars 1 time. Or excuse me, I'll start at the top of the table. I gotta go back up here. Right here for stripes. Let's figure out how many times we rolled the stripes. For me, the stripes are the yellow ones. It's this one. So we got that one exactly 0 times. We got that 0. Next are the white spaces. And for me, the white spaces are this one, and the pink, and the green, and the purple. Okay, so the white spaces are going to kind of mess things up. So we'll have to add them all together. So for this one, the cayenne, which is 2, and the pink, which is 4, and the green, which was 1. Are y'all keeping track of this? Because I think I lost count. And purple, which was 1. So 1, 2, 3, 4, 5. All right. Okay. So that's 5. And then the dots are this one, the lime color. So we got dots 0 times. And then the stars was the blue and red. So red and blue, which was 2. All right, I think I missed one. So purple was 1. I got to make my little tally marks here. And cayenne was 2. Pink was 4. Here's where I messed up. And then green was 1. That's 4, 5, 6, 7, 8. So the white spaces was actually 8. Okay, so there's our tally board. Let's go back over here now. I'll write that in there. So for here, our tally marks go 0 and 8 and 0 and 2. Sorry, it doesn't fit in there really good. And we had a total number of 10 spins, so we can just write 10 all the way down through here. Now, what's the experimental probability for this one? Well, there was 0 for that one. 8 out of 10. Oh, that looks bad. So 8 out of 10 for the white spaces. 0 out of 10 for the dots, and 2 out of 10 for the stars. So we'll just change this over and just write 0%, 80%, 0%, and 20%. Maybe that looks a little bit better. Okay. And then the very last question on this page says, are there any results which the theoretical and experimental probability were the same? Well, we would just compare that to the top and see that stars was 25%, so no, something other than the white spaces was 4 out of 8 was 50. That was actually higher, so no. For this one, not really. There weren't any instances where the experimental and theoretical probability were the same. And that's okay, because theoretical is a guess, experimental is what actually happens. Okay? And then the last page of notes for this one is talking about relative frequency. Okay? So for your little boxes up here at the top for your vocabulary, relative frequency is the total number of successful attempts divided by the total number of trials. It could be used to make graphs. This is where we usually get our data from when we are doing this scientific method and we are collecting data. When we get our data from the table, this is the information we use to make the graphs. It says, as the number of trials increases, the relative frequency of an event will approach the actual probability. Okay, so that means the law of numbers says that the more times you repeat a trial and that you test it out, the experimental probability, the results that you get are going to be closer to what your theoretical probability would be. And we're going to test that out with your little spinner. Okay, and I've already done that for the frequency of 100 times. I did that here. You can do this one for yourself. You can use your little spinner. I'm going to give you the results that I've got whenever I did this little test, just so we can have some numbers to put in here. And let's see. Maybe if I zoom in just a little bit, I'll have enough room to write it. All right. So for here, for the spinner, after spinning it 50 times, it tells us that we got a result. We spun a 1 12 times. So the relative frequency for this one would be 12 out of 50. And it makes it hard to read. But if we divide that out, we find that that's 24%. That's really hard to do. So 24% of the time, we got a 1 out of those 50 spins. Next, it is how many times did we spin a 2? Out of those 50 times, we got it 8 times. So 8 divided by 50, because it's how many times did we get it, divided by the total number of trials. And 8 divided by 50 is 16%. I need a better stylus. It's not working great. For 3 out of 50 spins, we spun a 3 13 times. So 13 out of 50, we would do 13 divided by 50. How many times did we get it? Divided by how many times we tested it. So how many trials? And 13 divided by 50 gives us 26%. And then we got a 4 10 times. So 10 times out of 50 translates to 20%. We would do 10 divided by 50. And then the bottom, the last one, we got a 5 7 times out of 50. And 7 divided by 50, because we get it 7 out of 50 times, it would be 14%. Okay. That's our relative frequency for spinning it 50 times. Now, spinning the spinner 100 times. Ideally, what we would see, since each one of these numbers, the actual probability is 1 out of 5 or 20%. That's the actual probability, because you have a 20% chance of landing on each one of the numbers. That's how many, or what the likelihood of spinning it one time. What's the chances of you landing on it on a 1, 2, 3, or 4, or 5? Each one of those is 20%. That's the actual probability. So what we would expect to see is that the more times that we spin it, the closer we get to this actual probability, which is 20%. And if you can see over here, my little table where I've already done it, when I spun it 100 times, my experimental probability, here's what I came up with. Theoretical probability, or my actual probability, would be 20%. So if you look at my little table, I have 25 and 19. Threes, I got 22. Fours, I got 15. And 5, I got 19. So my relative frequency for this would be 25 out of 100, because that changed. That's 25 times I spun a 1 out of 100. So 25 out of 100 times is 25%. For my number 2, I spun a 2 19 times, and 19 out of 100 is just 19%. I spun a 3 22 times. 22 out of 100 is 22%. I spun a 4 10 times. 10 out of 100 is 10%. And I spun a 5 19 times. Whoops. This was weird. 15%. I was looking at this number. For my second trial, I got it 15 times. So it's 15%. Okay, I spun a 5 19 times. And 19 out of 100 is 19%. So you can test that out. If you want to do your own trials with the spinner, I would suggest it. That's kind of helpful. And use your little spinner there I gave you the link for. Number 5 says, what did you notice as you spun the spinner 100 times? And what patterns did you discover? Well, the only thing that I kind of discovered as we were spinning that, which is kind of what should happen, was most of the numbers, not all of them, got closer to the actual, um, to its actual probability. There we go. There's the word I'm looking for. The first one, the blue one, let's see, 19%. That's actually this one. It went from 14% to 19%. So that one got a little bit closer. That one got closer to its actual. 25. So the number one went from 24% to 25. So this one actually got further away. So that one didn't work out that way. Um, number two, my number two here went from 16% to 19%. So that one got closer to its actual probability. The red one, or number four, went from 20% to 15%. So that one didn't get closer. And then the last one here went from 26 to 22%. So that one did get closer. So the observation that I made was more of the numbers got closer to its actual probability as we spun it 100 times. That was what I discovered. And then you may discover something different as you do your own experiment with it. Number 6 says, what is the theoretical probability of spinning each of the numbers? Well, I've already talked about that, and that was your actual, I guess I erased it. What is the actual probability? And the theoretical probability of spinning each of those is 20%. And that also shows you that in this table here when you do your trials on your own little spinner. It tells you that the theoretical probability for each of those is actually 20%. Then it says, how does the relative frequency change when the spinner is spun 50 times versus it being spun 100 times? Well, just like what I had stated, what relative frequency, based on what we know about relative frequency, is that most of the numbers should get closer to its actual probability, which is 20%. In this case, 3 out of the 5 did. And so that's what we should see happen. That as you continue and do more trials and more trials, then it would be closer to its actual probability. And then number 8 says, suppose the spinner was spun 1,000 times. Predict the relative frequency of each spin. Well, you can make a prediction for each of those and have them be closer to 20 than what they actually are. And really anything close to 20 or 20 itself, even if you spin it 1,000 times, the chances of all of them being exactly 20, it's not very likely. But they should be a little bit closer to 20 than they are now. So you can make up your own predictions for those too. I hope this helps when you're completing your homework problems. If you still have any questions, please feel free to email me or make sure that you're joining our Zoom sessions at 10 o'clock with Miss Bird and 2 o'clock with me. Tomorrow, Thursday, the 2nd, April 2nd, we will do a Quizlet Live game. Hopefully it'll be fun. Hopefully it's not too hard. But it'll be with these vocabulary terms from math that we went through. A couple of them, we looked at a couple of them to complete this sheet. So I hope you have a great day. Stay safe, stay healthy, and I will see you tomorrow.